Hi children, now we are going to discuss an important lab activity which is mentioned in your textbook, where we can learn the image formation when the object is placed at a specified position on the principal axis. So how exactly we are going to determine the object and image positions with known concave mirrors focal length. If the focal length of the concave mirror is known, how exactly you are going to determine the image distance and the nature of the image formed when the object is placed at a specified position. That is what we are going to learn now. So for that lab activity, I am going to say you what are the materials required. See, for every lab activity, initially you have to focus upon the aim. Aim in the sense for what purpose you are performing that activity. That is what the aim is. In this particular lab activity, we are going to determine the image distances and when the object is placed at a specified position and nature of the image. So what is the aim? To observe the image formation when object is placed at various positions in front of the mirror. And next to that, you are going to learn how the nature of the image would be. I will explain you what exactly do you mean by nature of the image. Nature of the image in the sense how the image looks, whether the image formed is diminished, whether the image formed is, what we say, is it enlarged, is it inverted, is it erected. All these terms you are going to learn in this particular lab activity. No need to get confused by the terms which I have used. By the completion of this particular lab activity, you will get to know what exactly those terms are. Now, after knowing aim, we have to concentrate upon the materials which are to be used to perform this lab activity. To perform this lab activity, step by step, I am going to write materials required. Materials required. What are the materials required? First, it is V-shaped stand. See, remember, this is one of the most important lab activity in the examination point of view. It can be asked for 4 marks. One of the most important lab activities in the chapter 1. V-shaped stand, which is used to place concave mirror in it. In that we will put the concave mirror to perform the activity. Next to V-shaped stand, we need a candle. We need a candle which is light source and which is nothing but object in this activity. Object in this activity. Next, third one, a screen. Screen in the sense, let it be a white paper. See, whatever the way I am explaining this lab activity, that is the way you are going to present this answer in your examination. Next, 4, a meter scale. A meter scale which has markings upon it, 1 centimeter, 2 centimeter, 3 centimeter, like that. 1 meter is equals to 100 centimeters. So 100 centimeters would be marked upon that scale. Such kind of a scale would be considered. Next. Yeah, that's all. These are all the requirements are. And a important thing, very important thing we have forgot. The most important thing is a concave mirror. Concave mirror whose focal length is known to us. Known focal length. So what is the use of a concave mirror whose focal length is known? I am going to say now. After this, as soon as you know what materials has to be used to perform this lab activity, immediately you have to focus upon the science behind performing this activity. If you know the science, then only you can perform the activity. Without knowing the science, you cannot perform lab activity. So what is the science behind the image formation? I will let you all know what is the science behind image formation. Because now all the time I am discussing about the image formation, right? In the aim also I have focused, I have emphasized upon the image formation. So what exactly is this image? How the images are formed? To say this, it is the principle, not principle. The science behind the activity is called as principle. The principle behind this is the image is formed. Image is formed where the reflected rays meet. This is the principle. The image is formed where the reflected rays meet, where the reflected rays intersect. At that point, the image would be formed. That is the principle behind this activity. Now I am going to say you what is the use if we know the focal length of the concave mirror. When the materials required was written, I have written that we must know the focal length of the concave mirror. So now I am going to give you an important information which you have to know, and it is useful at the time of problem solving in this particular lesson. If you know the focal length, remember, focal length, if you know the focal length, so first of all, what exactly is the focal length? I don't know focal length itself, but sir, you are using the term focal length. What do you mean by focal length? The distance between pole and focus of the mirror is nothing but focal length. So if you know the focal length, it would be half of the distance of the radius of curvature. Now again a new term, you have encountered a new term again, that is radius of curvature. What do you mean by radius of curvature? The distance between pole and center of curvature is nothing but radius of curvature. Now, focal length would be half of radius of curvature, means r by 2 will give you focal length. That means 2 into focal length would be equal to radius of curvature. 2 into focal length would be equal to radius of curvature. Now you see, let me show you through a diagram then you will get a clarity. You will get a clarity. This is concave mirror. Now I am going to draw a principal axis. I already told you principal axis is nothing but a normal which is passing through pole. Pole నుంచి పాస్ అవుతున్న నార్మల్ ని ఏమంటారు? ప్రిన్సిపల్ యాక్సిస్ అంటారు. అంటే ఇది కూడా ఒక నార్మలే. ప్రిన్సిపల్ యాక్సిస్ కూడా ఒక నార్మలే. రిమెంబర్ దిస్. Now I know center of curvature. Remember the half of the distance between pole and C would give you focus. Means the distance from P to F would be equal to F to C. This is the same distance. PF is equals to FC. PF is equal to FC. Focal length is equal to the distance between focal length and center of curvature. This is what, by knowing the focal length, you have this information. You have this information means if you know the focal length, ultimately you indirectly has given you the center of curvature also. Radius of curvature from pole you move on the principal axis till the radius of curvature. అంటే నీ దగ్గర radius of curvature 8 meters అని ఇచ్చాడు. Let us suppose it is 8 centimeters. Let us suppose it is 8 centimeters. Now you start moving from pole on the principal axis 8 centimeter distance away. Then you will encounter center of curvature. Let us see now actual methodology of the activity. What we perform in this activity? I already told you, placing the object at various positions, we will observe the image, how image is formed. Okay, see, we have put a V-shaped stand. V-shaped stand in the sense, in that V-shaped stand there will be a slot, there will be a gap. Within that the concave mirror will be seated in. The concave mirror will be seated in like this. The concave mirror will be facing that side. Okay, remember the concave mirror will be facing like this. Yeah, it might be a bit bad, but try to bear with me. Now you place a meter scale over here. You place a meter scale which has markings upon it. As I told you, there are markings upon it. Let us suppose we are supposing the focal length. As he told, we know the focal length. We are supposing the focal length as 20 centimeters. Let the focal length be 20 centimeters. So let the here would be 20 centimeters. That is focal point, focus. And I already told you the pole exists over here at the center of the mirror. The geometrical center of the mirror is nothing but pole. Means pole would be somewhere, the pole point would be somewhere here. Means when you consider straight away from the mirror, the pole distance would be here at the origin. Pole is nothing but origin. You move 20 centimeters away, there will be focus. You move another 20 centimeters away, you will get center of curvature. I already told you the distance from P to F would be equal to F to C, or else you double the distance from pole to focus. If it is 20 centimeters, then pole to center of curvature would be 40 centimeters. Remember, if this is 20 centimeters, then obviously from pole to center of curvature it would be 40 centimeters. Now you try to observe. I already told you the object is nothing but candle. So you take the candle and put beyond this sea. Ensure that the flame lies above the principal axis. If the pole is over here at the middle of the concave mirror, mirror మీదనే ఉంటుంది. ఆ పోల్ ఎప్పుడైనా మిర్రర్ మీద ఎగ్జిస్ట్ అవుతుంది. నాట్ లైక్ సెంటర్. సెంటర్ అయితే దూరం ఉంటుంది. ఇఫ్ దిస్ ఈస్ ద కర్వ్, ద సెంటర్ లైస్ సమ్వేర్ ఓవర్ హియర్, బట్ ద పోల్ లైస్ అపాన్ ద మిర్రర్ ఇట్సెల్ఫ్. పోల్ మిర్రర్ మీదనే ఉంటుంది. ఓకే, పోల్ నుంచి ఒక నార్మల్ కొడితే ఎలా ఉంటుందో దానికంటే పైకి you try to consider this flame. You try to consider that the flame lies above the principal axis. Now you try to see here, the object is placed beyond C. Beyond C and C దాటిన తర్వాత beyond center of curvature. Now the image formed, see from here the light rays, see this is the candle, that is the source. The light rays come and fall upon the mirror. The light rays come and fall upon the mirror. Now there will be a screen. I already told you, a plain sheet of paper. Then you start moving this plain sheet of paper here. Move. You have a plain sheet of paper with you like this. Let us suppose this is a plain sheet of paper. Upon a meter scale you start moving this plain sheet of paper. After coming here, somewhere you can see there is a flame. There is a flame which will be visible like this. The image of this flame was formed over here by intersection of the reflected rays of this. ఇక్కడ నుంచి వస్తున్న రిఫ్లెక్టెడ్ రేస్ ఇక్కడ మీట్ అవుతాయి నాన్న. దట్ ఈస్ హౌ ద ఇమేజ్ వుడ్ బి ఫార్మ్ హియర్. ఇది అప్వర్డ్ ఇమేజ్ ఎట్లా ఉంది, డౌన్వర్డ్. రిమెంబర్, ఇఫ్ దిస్ ఈజ్ ద if the flame is upward, the image would be downward. You can see a smaller image. Let the principal axis here it would be a smaller image. Okay, upon the screen you can see a smaller image. Means I told you we are going to understand the nature of the image also. We are going to understand nature of the image. When you started moving the screen, it is found somewhere between 20 to 40 centimeters. Means let us suppose it is found at some 28 centimeters. The screen when it was 28 centimeters, at 28 centimeters upon the meter scale, you have seen this image. Let us suppose you have seen this image. How the image would be? It would be in an inverted position. See, if this is the principal axis, if the flame is upward, here the flame was downward. That is why you will call it as inverted image. Inverted image. Next, you can see the flame size is bigger over here. Means the object size is bigger, but image size is smaller. That is why it is called as diminished image. Diminished image. Image is formed between F and C. Image is formed between F and C. Diminished image, inverted image, image is formed between F and C. There is one more nature of the image. If the image was captured upon the screen, if the image మనకి స్క్రీన్ మీద కనిపిస్తుంది, పేపర్ జరుగుతున్నప్పుడు పేపర్ మీద you are able to see the image. అక్కడ క్యాండిల్ పెడితే the candle was placed somewhere over here. Let us suppose the candle was somewhere here and I started moving the screen like this. Then I was able to see the image upon the screen. The object was placed here. This is the flame. Let the blue color be the flame. You can see an inverted blue color upon the screen. Then if you are able to see image upon the screen, then the image is said to be real image. Image is said to be a real image. Next, we shall go to the case 2. When object is placed at center of curvature. I just move this object at the center of curvature. Now, it's an interesting thing. You can observe the image formed was inverted. Screen just put us up. We start moving the screen. At the center only you can see the image on the screen. Inverted. If you are able to see image on the screen, that is real image. Inverted. And next to that, try to remember. Next to inverted upon C itself. Image is formed at C only. When the object is placed at C, the image is formed at C only. Remember, if object is placed beyond C, then the image is formed between F and C. If the object is placed at C, image is also formed at C. Next to that, the image size will be same size as object. ఈ ఫ్రేమ్ ఏ సైజ్ ఉందో ఇమేజ్ ఫ్రేమ్ కూడా అదే సైజ్ లో కనిపిస్తుంది మన స్క్రీన్ మీద మీకు. now I am changing the position further. Now this object moves between F and C. F की C की मध्य ऑब्जेक्ट ఉంది నా ఇప్పుడు. Try to remember. Now the image formed would be beyond C. Here it is C, right? C కంటే దూరం ఫామ్ అవుతుంది. Image size will be bigger, larger. So that there you can write. It is also inverted image only. If you start moving the screen, each side screen జరుపుకుంటాం, we can't find the image. Screen each side జరుపుకుంటాం. Then you can see the image formed beyond the C. Image is formed beyond C. Next to that, the image size was enlarged. See, you observe the size of the image. ఇది చిన్న ఉండే ఇమేజ్ సైజ్ ఏమైంది, పెద్దదైంది అంటే enlarged image అన్నమాట. This is enlarged image. Image formed is beyond C and the image formed is enlarged, and image is a real image. Image is a real image and inverted image. Almost in concave mirror, all the images would be inverted only. In only one case it would be different. Okay. Next to that, we can see when the object is placed. See, real image, as long as the image is captured upon the screen, it is called as real image. Now the object is moved upon to the focus. Object దగ్గర పెట్టినాం, focus దగ్గర పెట్టినాం. The distance at which the focus was lying, there the object was placed. అంటే ఇక్కడ focus ఉంది, ఆ focus దగ్గరనే object పెట్టినాం. Now what happens, you start moving the screen. ఈ మీటర్ స్కేల్ మీద స్క్రీన్ ని మూవ్ చేస్తూ you cannot find the image. Image will be formed somewhere at infinity. Image is formed at infinite distance. అంటే చాలా దూరంలో ఇమేజ్ ఫామ్ అవుతుంది. You can see upon the screen, but it would be very far away. Okay, and it is real image. Only these two I can say. The image enlarged and the diminished and you cannot say, because it is formed at somewhere infinite distance. Now I move the object between F and C. F की C की मध्य object बैठा. The object is placed between F and C. Now interestingly, the image won't be observed anywhere upon the meter scale. Screen జరుపుకుంటూ and you start moving the screen upon the meter scale, you cannot find where the image is. Why the image is not formed upon the screen? The image is within the mirror itself. You can see this flame in the mirror. You can see the same flame in the mirror with an enlarged size. The image, when it is placed, the object is placed between P and F, mirror and F, then the image form will be in the mirror. Image form is in the mirror. Can you capture this image on the screen? No. Then such kind of images which you cannot capture upon the screen, the images which cannot be captured upon the screen are called as virtual images, and the image size will be enlarged. Remember, the image size will be enlarged. Virtual, enlarged, and you can see the image will be erected. See, in the same way we reverse the forming. The images are formed in a reverse manner, but the image here formed is in erected format. Erected and how the object is there above the principal axis, the image will also be above the principal axis. That is why it is called as erected image. Now we try to see when the object is placed somewhere at infinity. A candle named down, we should take this candle to somewhere farther distance. You take this to the farther distance, the image will be formed at focus. That will be point image. Diminished. When object is placed at infinite distance. Now you have observed various positions of the images when object is placed at different positions, and you have known the nature of the image. Nature of the image, if anyone asks you what is the nature of the image, you have to say whether it is erected or inverted. You have to say whether it is a real or virtual image. You have to say whether it is diminished or enlarged. Okay, these three says the nature of the image. That's all for this session. In the next session, we'll try to learn the principles behind drawing the ray diagrams. You may not know what is the ray diagram. That will be discussed in the next session. Bye bye.